if you're doing BPM correctly, there is a problem that you end up developing that sounds like a feature, but it's really not. The problem is that you will end up making changes and developing so very quick that your QA team won't be able to keep up. They are probably using Selenium or something like that, and they are going through and they are creating tests for every one of the screens that you have and the expected inputs and the outputs. And what you're going to find is that every time that you want to make a change to your process or do an improvement or anything along those lines, they're going to groan and they're going to ask for more budget and they're going to ask for more time. And eventually that's going to become a disinclination for you to innovate on your process. You'll start taking your innovation inside of the code that you're calling RESTfully, and that in turn will lead you to eventually go back to your traditional software development environment. What I'd like to do is show you how Capital BPM is addressing this problem. So right now, as you can see, I'm building a process that has multiple gateways in it. So this is like, if we had decided that something was approved or not approved, we would have taken one path or another path. And you can imagine that as your gateways start nesting in on each other, all of this becomes very complicated. So not only do you potentially have to change the UI in order to support this sort of a process, but you potentially have to change the testing of the business logic. So the way that Capital BPM has decided to address this is to build a tool that we call Sentinel. And what Sentinel does is that it actually goes through and it automatically examines every single possible path through your process. So it does this at runtime. It looks at all the gateways, all the events, all the timers, anything that could change. And it automatically generates a scenario for you. So, hey, this is if the answer was yes on the first gateway versus this one being the answer being no. Furthermore, Sentinel will actually go through and help you either randomly generate or generate data as you see fit for each one of the steps of the process, and then compare what actually happened to what you expected to have happened, so you can determine if a test is successful or not. So what you're seeing me do right now is actually build a process with multiple gateways, and it has scripts inside of it, and it has human tasks, and what we're trying to do is find a way to test this. So you're going to see me in just a moment deploy this, and I'm going to turn right around, go into Sentinel, and then create a runtime test for you of the same thing. What I want you to understand is that, one, this is happening at runtime. So I didn't prepare this beforehand. I'm building this as we go along. And two, I want you to know that because it's happening at runtime, I can make changes to the process and I can inject those into the test again and again and again. So what we are finding is because the process itself is fairly robust and is able to be tested and empirically proven to succeed, then it actually becomes a lot more amendable to progress because you can change it, you can prove that it works, and you can go on from there. Now, what we are finding is that a lot of our customers are using this not just for QA, but also for requirements gathering and for validation of tickets as they're being developed. So, for example, you can imagine that if you're a believer in test-driven development, that you might actually write a test like this for a process before, say, all the integrations are in place. And the criteria of actually passing the test would be that, hey, if I go from step 1 to step 2 and I enter a customer with this credit score and this much income, then we expect them to be approved, or we expect them to be rejected, or we expect a certain amount of interest or so on to be applied to them. So the idea is that the tests can be written beforehand. And all these tests, incidentally, can be automated. So the tests themselves can be triggered by your CI/CD. They can be run in bulk. They can be driven by your QA team, by your testing team, by your development team, even by your managers. The tool has the ability, for example, to automate a scheduled test, like say run 100 tests at 2 o'clock in the morning, generate a report, and then send that out to an interested party, or even make a RESTful call to say log into Jira that, hey, this test failed. So what this does, it allows your best testing practices that you know from your other development languages to be utilized as a part of BPM. Okay. So with all that talking, it's taking me about 5.5 minutes to build this process. And now I'm just going to go into Sentinel and I'm going to log in. And you can see here that I've chosen my server. I'm going to choose the process. And you can see immediately that the same process I just deployed is available for testing. I tell the tool to auto-generate a path. And you can actually see here that within the context of the tool, it has highlighted one path through everything that you can do. So all the steps are articulated. And I'm going to come here and I'm actually going to inject a variable that is approved variable into scenario number 1, path number 1. And I'm going to say, hey, initially approved is equal to true. Now, as soon as I'm done with this, I'm going to define an output criteria for success. So I'm going to say, hey, my expectation is that at the end of this process is approved will be equal to true or will be equal to false. And I'll change this as we go along to make sure that I can show you how this works. So in this case, I'm going to say that I expect is approved to be equal to false. So now that I've done it, I'm ready to go. I can come in and I can say, I want you to run this process. The tool runs the process. And you can actually see here that it's highlighting the path that it actually followed. And you can see that this test was passed. Now I want to show you how quickly you can change and evolve these tests. So I'm going to come back and I'm going to change the test to say true initially, so that I'll run the test again. And you can see here that it actually is following the upper path. So it's going from step 1 to step 2 to step 5 and now to step number 8. But it's still considering the test to be passed. Now I'm actually going to go in and I'm going to put in a check on the output to make sure that by the time I get to step 8, for example, that the debug that I put in initially actually has a particular value. Now I'm deliberately going to set this up to have a string that I know is not in there. And I'm doing this to show you that these tests can flag the fact that a test is passed or that a test is failed. So we come over here, we run it again, and you can see even though we got to the end, it shows that we failed the test, and it tells you exactly why we failed it. And you can actually see here that it's because the debug value did not say, hey, this is great. So one final thing that I'm going to do is I'm going to go and I'm going to change the value of debug. And I'm just going to say, hey, I just want to make sure that debug is not empty. So again, I save it. I run the test again. And you can see here that this time it passed. Now, I've shown you about 5% of what we can do here. I haven't talked about combining scenarios or overriding timers or being able to override identities or trigger events. There's a lot here. But I think this is a good introduction of the kind of problems you have to solve when you think about testing with Commando.